In this video, we're going to walk through some examples of how to assign oxidation numbers to elements within a larger compound. Our first example is dinitrogen tetraoxide. So we're always going to start assigning oxidation numbers by looking at an element that we have rules for. In this case, we have defined rules for oxygen. So as a refresher, oxygen can have three oxidation states. It can have an oxidation state of 0 when it is in its elemental form. It can have an oxidation state of -1 when it is in a peroxide. And it can have an oxidation state of -2 when it is in other compounds. Because dinitrogen tetraoxide is not a peroxide, in this compound, oxygen will have an oxidation state of -2. Now, I'm going to write the oxidation numbers of individual atoms above the compound. So in this space here, this is going to be the oxidation number for individual atoms. I'm then going to take that number and I'm going to multiply down. So 2 times 4, that's going to give me the total oxidation number for oxygen. So at the bottom here, I'm going to have the total oxidation number from each element. And the reason that I want to do this is we know that the total oxidation numbers must add up to the overall charge on the compound. So N2O4 is neutral, so -8 plus whatever the oxidation contribution from nitrogen is has to equal 0. And so in order for that to be true, nitrogen must have a total oxidation number of +8. We are now going to divide by the coefficient, which is 2, and each nitrogen is going to have an oxidation state of +4. We're going to look at a slightly more complex example now. So we have 4 different atoms here. At first glance, this looks a little confusing because we don't have rules for sodium or sulfur necessarily. Whenever we have an ionic compound, we're simply going to dissociate it before we start any before we assign any oxidation numbers. So sodium is a simple ion. It's going to have a total oxidation number of +1. Hydrogen sulfate is a polyatomic ion. You can find this in your polyatomic ion chart. It has an oxidation number of -1. That means that the total oxidation state of the elements must add to -1 for hydrogen sulfate and must add to +1 for sodium. That makes sodium pretty easy to assign. So because sodium must add to +1 and there's only one sodium, the sodium atom in this compound will have an oxidation state of +1. Hydrogen sulfate must add to -1, and we have rules for 2 of the 3 elements here. We have rules for hydrogen and rules for oxygen. So oxygen is going to be -2. So it's not a peroxide. That gives us a total contribution of -8 from oxygen. Hydrogen has 3 possible oxidation states. So hydrogen can be 0 if elemental, so in H2 form. Hydrogen can be +1 in most compounds. Or it can be -1 in hydrides. This is not a hydride, so hydrogen here will have an oxidation state of +1. Since there's only one hydrogen, its contribution will be +1. So what we are dealing with here for sulfur is +1 plus whatever the oxidation state of sulfur minus 8 equals -1. And so sulfur is going to equal +6. So 1 plus 6 is 7, minus 8 is -1. So sulfur will have a total oxidation number of +6. Because there's only one sulfur, it will be +6. Lastly, we're going to look at a polyatomic ion. So a polyatomic ion has an overall charge. In this case, that charge is -2. And so we're going to start by assigning our oxidation number for oxygen, because it's something we have a rule about. So oxygen will be -2. There's 3 oxygens, so that gives us a total of -6. We know that the total oxidation number must add to -2, because that's the charge on our ion. And so we can deduce that sulfur must have a total contribution of +4. +4 minus 6 is -2. Because there are 2 sulfur atoms in our compound, we're going to divide that +4 by 2, giving us an individual oxidation number for both sulfurs of +2.